All right, now we're going to do the distance formula, station 4. Okay, everybody get ready. Number 1 reads, given point S is at 7, 3, and point T is at 1, -5, find ST. That's find the measure of ST. See how there's no line above that? Okay, so the first thing that we should do is label our points. We always use x1, y1, x2, y2, and you can put that on the top or the bottom. I put it on the bottom because there's not enough space. And we're trying to find the measure or the length of ST, so we need the distance formula. And our distance formula is x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So it's the difference of the x's and the difference of the y's. So now all we have to do is substitute the values in that we have. My x2 is 1. My x1 over here is 7. I'm going to square that. y2 is -5, and y1 is 3 squared. 1 minus 7 is a -6. 6 squared is 36. -5 minus 3 is a -8. Squared is 64. And 36 plus 64 is 100. So the distance is 10. So ST, the length of ST is equal to 10 units. Number 2, what is the distance between points M and Z to the nearest tenth? Okay, we want to know the distance between points. So that means we're using, again, the distance formula. I'm not going to write it again because I have it right up here on my paper, but I am going to label my points. x1, y1, x2, y2. Now I'm going to substitute their values into the distance formula. x2 is -1, x1 is 6, y2 is 14, y1 is -16. -1 minus 6 is a -7 squared. Uh, 14 minus -16 is 30 squared. 7 squared is 49. 30 squared is 900. So the square root of 949 is 30.8. And that is the distance between MZ. Okay. On a zipline course, you are harnessed to a cable that travels through the treetops. You start at platform A, and you see on this diagram, they've given you a point A, and zip to each of the other platforms. Zip, zip, zip. Which is the platform that is closest to you at start? So you see we have platform B and platform C. So we need to know, is it shorter from A to B or from A to C? So we're talking about distance. And I could see this right here when I said, which platform is closest? So let's look and set up our problem. Point A is at -20, 20. Point B is at -40, -30. Okay, so I want to know the distance from A to B. I'm going to label so I don't make a mistake. This is my x1, this is my y1, this is my x2, y2. And now I'm going to substitute their values into the distance formula. My x2 is -40, minus my x1, which is -20 squared, plus my y2, which is -30, minus my y1, which is 20 squared. So this is going to tell us the distance from A to B. If we're going from A to B, this is the distance, because we use points A, B in the distance formula. So, -40 minus 20, minus a -20, so it's a -40 plus 20 is a 20, a -20 squared is 400. Ooh, big numbers. Plus, -30 minus 20 is a -50 squared, so that's 2,500. 400 plus 2,500 is 2,900. Square root of 2,900 is approximately 53.9. So the distance from A to B is 53.9. Now we need to do the same thing to find the distance from A to C. See this distance here. So A we knew was at -20, 20, but now we're going to use point C, which is at 30, 10. See this line right here, that's 10, but it's right before the 20 up there. Okay, we have to substitute it into the distance formula. And we're going to say AC, the distance from A to C is equal to let's label x1, y1. This is my second point, y2. Okay, label your points. So my x2 is 30 minus a -20 squared plus y2, which is 10 minus 20 squared. 30 minus a -2, that's a positive 50 squared, plus 10 minus 20, which is a -10, is a 10, I'm sorry. No, it is a -10 squared, which is 100. So 50 squared is 2,500 plus 100. Woo, big numbers. The square root of 2,600 is the distance from A to C, which is approximately 50.9 units. So since 53.9 is longer than 50.9, the distance from A to C is shorter, so C is closer to A. So which platform is the closest? C.